Today I'm going to do my presentation on green crude, another name for algae. So a lot of this is going to be specifically on algae, but we'll go over biodiesel as a whole also. And the presentation was a webinar of two people, one William Thurman and another was Barry Cohen. They were both a part of the National Algae Association. Barry Cohen being the president and the banker. He's a banker while the other one's a scientist, is an engineer. And he's also the head of a capital fund for biofuels. And Will Thurman was, he's a marketing expert, got his degree in science, but he does most of his research for the National Algae Association. He's actually the chairman of research and development. Some algae basics. Most algae, this is a rough estimate, 30% oil, 30% protein, and 40% carbs. And there's about 3,000 strands of algae, and about 10% of those have oil. And officially, as of 2 or 3 years ago, all big oil is invested in green crude, which is Chevron, Exxon, BP, Shell, all the above invested because it's created jobs and well, it makes them look better to be involved in the green movement. Biodiesel from algae process. This is an image. Walk through it. I'll give you a simple description. First of all, they grow the algae, and there's a few different processes that we'll go over later to do that. And they starve it of nutrients, and then they break it apart. And they break it apart to get the fats and the sugars out. And they use a solvent to separate these fats and sugars. And after that, they evaporate off the solvent, and then they transform the fat to the biodiesel, and they transform the sugars to the alcohol. So, potential markets for green crude. A bunch of these are listed. These are some of the main ones, but there's a lot of different uses for green crude. You have biogasoline, plastics, cosmetics, pharmaceuticals, different livestock feeds, poultry feeds, fish feeds, and organic fertilizers. Efficiency of different feedstocks. In the United States, we use usually soy and corn. They're actually about the same. 40 to 50 gallons per acre can be produced from soy feedstock. Canola and rapeseed are used widely in Europe, and that's the yellow flour, and that's 120 to 150 gallons per acre. And eutropha is used in South America, and it's also used in India. Their whole biofuels is based off of eutropha. And that is a small flour that's resistant to pests, and it's also resistant to drought. So it's very useful in arid climates. And that's the next one's palm, which is gotten in Africa, and it's from a reddish pulp. And the last one is algae, what we'll be talking about. And that's obviously the most productive and most efficient feedstock out of all of them, since it's 5,000 to 10,000 gallons per acre. How fuel affects the United States. More than 95, this is just a fact, more than 95% of our cars and motor vehicles use gasoline compared to many of the other industrialized nations. 50% of our corn replaces 10% of our oil, obviously mostly in the form of ethanol, and we really can't produce enough corn or soybean to meet the oil needs. And also it affects international affairs for the United States. Obviously, we're thinking about Syria now in the Civil War, or Iran if they were to develop nuclear weapons, and then the 1973 oil crisis with OPEC. That really all affect the oil prices and give us an incentive to be involved in biodiesel, biofuels, and algae. And how algae could affect the U.S. Since 50% of our corn supply substitutes for 10% of our oil, we could replace 17% of our oil imports with just using algae. And therefore, we can put more food on the table and not have to go through all the other agricultural subsidies that we do. And algae can be produced every single day. And actually, it can be harvested, if it's the right process, can be harvested 2 to 3 times a day. And as we saw earlier, it produces more oil than any crop and is more productive than any other biofuel at this time. And how it affects how fuel affects the European Union. Compared to us, 50% of their cars are actually run on diesel. And they have a massive shortage of feedstock, which is a rapeseed and sunflower. And since the European Union doesn't really produce a lot of oil compared to even us, but especially to the Middle East and other areas. They've had a lot of more environmental regulations on this and other things. Of course, their cars being on diesel, and they would have to get their oil from other places or increase their use in biofuels. How it affects China. There's a rapid construction of coal-fired power plants. I think, we've talked about this before. I think Dr. Jones talked about in chem processes. The 2 coal-fired power plants of 500 megawatts each. 2 of those go in every single week for the next 10 years, approximately, in China. Instead of going to an alternate fuel, and their goal is to be 15%, use 50% of biofuels for transportation. But their biofuel, compared to the other things we've looked at, is actually just waste vegetable oil. And lastly, how it affects India. Y'all probably know this, but India is going to be the most populous country very, very soon. And it produces very small amounts of oil, and they have very few natural resources compared to most of the other places in the world. And hopefully it's not going to take us to get into a crisis like they did with their population and such, but they had to have a national biodiesel standard, and they used the TROFA, and right now I think 15 to 20% of their oil is from just that plant for biodiesel in order they don't have to import so much and they really can't produce much oil. And here's the graph I put together comparing from 2002 to 2010, the 4 areas I spoke of, and we have had the same consumption for over 8 years, which is an anomaly compared to the other countries, and we've actually had an increase in production with North Dakota oil sands and with also Pennsylvania and Ohio fracking. But compared to the rest of the world, you can see that the consumption is increasing and their own production is decreasing. Last few slides talks about kind of the business process of algae and the different methods of using algae. First of all, is the evolution of algal producers. Is we have a lab scale technology that's testing what we're doing, and testing and researching the different biofuels and how they affect, kind of what I've been talking about earlier. And the next is the pilot scale project, or universities and businesses use it to test and see how they run compared to other factors. And it's kind of proof that the biofuels are being used for what they're supposed to be used for. And the demonstration scale projects is when they're actually put onto the line and tested in different businesses. And after that, they see how they can scale it up for more wide use. And the commercial market is when we want to get fuels, we want to produce a large quantity, since people are going to keep buying them and buying them and buying them. And you'll have economies of scale, which you'll have an increase in quantity, and we'll actually be able to decrease the price of biofuels instead of being a commodity like they are now. We'll decrease the average cost. And the 3 phases we're going to have to invest in biofuels to do that. And 3 phases is the public-private partnerships for research and development, and the National Renewable Energy Lab partners with the first one to partner with Chevron to do a whole lot on biofuels. And some private companies invest in algae. Alginol is one of them, and they are involved in bioplastics. And another one is Sapphire Energy, who the Gates Foundation has actually given hundreds of millions of dollars to, because they've been able to use green crude to give to petroleum refineries to be used in the aviation industry for aviation fuel. And lastly is algae commercialization, which is what I spoke of as the last phase of the algal producer process. And you can have small commercialization, medium, and large. And small is cosmetics, medium is feedstock, and large, of course, would be fuel. This is just an example of how they grow some of the algae. This is a vertical growing column, and some of them are horizontal growing columns. And they also do algae farming in ponds, in recovery ponds. And they look kind of like wastewater ponds, but they're a whole lot prettier. And they're much larger and more efficient in a lot of ways. But the vertical growing columns put out about 20,000 to 200,000 gallons per acre per day, compared to the ponds, which is 5,000 to 7,000 gallons per acre per day. And with these columns, there's also no contamination or any ambient effects from the air, as there is with ponds. Conclusions, biofuels create jobs, as we've seen with the public-private partnerships. Biofuels create a chance for regional oil, so you don't have to depend on other nations or international affairs to affect your oil supply. And lastly, algae is the best fuel alternative compared to the other alternatives we looked at. Any questions?